Hello everyone, welcome back to Rare Chem Official. Today we are going to discuss about dipole moment. It is denoted by mu. Mu equals to Q into D. It is a charge, it is distance. When a covalent bond is formed between two similar atoms or similar electronegative atoms like H2, F2 and O2, the shared pair of electrons situated exactly between two atoms, that is called nonpolar covalent bond. If take H2 molecule, hydrogen has one electron less to duplet structure, and this is other hydrogen atom. If shared two electrons, the bond covalent bond is formed between two hydrogen atoms, and the electron shared pair of electrons exactly between two atoms, because two atoms has similar electronegativity and it is electron cloud is symmetrical. If a covalent bond is formed between two dissimilar atoms like HF, the shared pair of electrons gets displaced more towards fluorine. Since fluorine is more electronegative than hydrogen, the bond is called polar covalent bond. If take HF molecule, fluorine has more electronegative than hydrogen. It pulls electrons towards fluorine, and electron density is more towards fluorine. The electron cloud is towards fluorine, means hydrogen mm, it holds less electrons towards hydrogen. It fluorine, it has more electronegativity, so it pulls electrons towards fluorine. The electron cloud is more towards fluorine because of electronegativity is more. Dipole moment, charge on dipole equals to distance between the two poles. Here HF molecule, fluorine is more electronegativity than hydrogen. It pulls electrons towards fluorine. The partial positive charge is appears on hydrogen, partial negative charge is appears on fluorine. This is two poles. It is called as dipole moment, means the crossed arrow is towards positive to negative, and less electronegativity to more electronegativity. It is called dipole moment. Dipole moment is a vector quantity. It is represented by crossed arrow. The crossed arrow is on first cross is on positive end, and arrowhead is on negative end. Means if take one example HF, this is positive end, this is negative end, because partial positive charge appears on hydrogen, partial negative charge appears on fluorine. So partial positive charge to negative charge, and hydrogen is less electronegativity than fluorine, less electronegative atom to more electronegativity. This crossed arrow indicates that is on that only, means less electronegativity atom to more electronegativity atom. Dipole moments helps in the determining polarity. Dipole moment can distinguish between symmetrical and non-symmetrical molecules. If take CO2 molecule, carbon has less electronegative than oxygen. The crossed arrow is towards oxygen, and this CO, this carbon has less, and oxygen has more electronegativity. Crossed arrow indicates like this, and means the less electronegativity atom to more electronegativity atom. The net dipole moment is equals to 0. It is a non-polar molecule. NH3 has higher dipole moment than NF3 because of hydrogen has less electronegativity than nitrogen, and it has lone pair electrons 1, and the crossed arrow is towards more electronegative atom. The net dipole moment is not equals to 0 because of all vectors are same direction, and it is a polar molecule. If take NF3 molecule, it is also has one lone pair electron, three bond pairs, and a fluorine has more electronegative than nitrogen. It towards fluorine, and all vectors are in opposite direction, and net dipole is equals to 0. It is a polar molecule. Cis and trans, if two molecules are present, cis and trans, the cis isomer has more dipole moment than trans isomer. If take two similar atoms are in same direction, that is cis isomer. If two similar atoms are in opposite direction, that is trans isomer. See, cis means two chlorines are present in same direction. Chlorine has more electronegative than carbon, it is towards chlorine. Hydrogen is less electronegative than carbon, so the crossed arrow is towards carbon. The hydrogen and chlorine, these vectors are not cancelled, so net dipole moment is not equals to 0. Trans isomer, these vectors are in opposite direction, so net dipole is equals to 0. Trans isomer has less dipole moment than cis isomer. But in exceptional case, see here, it is cis isomer. See, so two similar atoms are in opposite direction, that is trans isomer, and two similar atoms are in same direction, that is cis isomer. If takes trans isomer, here hydrogen has less electronegativity than carbon, the crossed arrow is towards carbon, and this carbon and hydrogen, the crossed arrow is towards carbon because of electronegativity is more for carbon, and here the single bond has less electronegativity than double bond, so the crossed arrow is towards double bond. Chlorine is more electronegativity, so it towards chlorine. The net dipole is not equals to 0 because these two directions cancelled by each other, but these two are same direction. The trans isomer is not cancelled because this net dipole moment is not equals to 0. And if take cis isomer, 2 this hydrogen has less electronegativity than carbon, this crossed as is towards carbon. This double bond is less electronegativity than double bond, the crossed arrow is towards double bond. Here chlorine has more electronegativity than carbon, the crossed arrow is towards chlorine, and here hydrogen is less electronegativity, the crossed arrow is towards carbon. Here these two are cancelled by each other, but these two are not cancelled. This cis isomer also has dipole moment, but here similar, if comparison between cis and trans, here similar atoms are same, CH3 and Cl, here H and Cl. Here dipole moment is somewhat more, here hydrogen is somewhat less because of electronegativity difference, and trans isomer has more dipole moment than cis isomer. Actually cis isomer is present, the cis isomer, if cis and trans isomers are present, the cis isomer has more dipole moment than trans isomer. But here exceptional cases we have to observe that some cases trans isomers has more dipole moment than cis isomer. Dipole moment is greatest for orthoisomers, then meta, then para isomers. If a molecule is AB2 type, if take BeF2, this BeF, fluorine has more electronegativity than beryllium, and the crossed arrow is towards fluorine. This if take this BeF, this crossed arrow is towards fluorine, the net dipole moment is equals to 0 because these vectors are in same opposite direction, cancelled by each other. It is a non-polar molecule. If a molecule is AB3 type, if take BF3 molecule, this boron and fluorine has more electronegativity than boron, so it crossed arrow is towards fluorine. All vectors are in different direction, the net dipole is equals to 0. It is a non-polar molecule. If take SO3 and SO2, here SO3 molecule, oxygen has more electronegativity than sulfur, it is towards crossed arrow is towards oxygen because of electronegativity is more for oxygen, and here all vectors are opposite direction and cancelled all, and net dipole moment is 0. It is non-polar molecule. If take SO2, this SO2 Oxygen has more electronegativity than sulfur. The crossed arrow is towards oxygen, and this is also similar only. But lone pairs also has some dipole, means some energy or some electronegativity. So the basic rule is um, lone pairs also has more electronegativity than others. If lone pairs are present, the molecule is almost 99%, that is polar molecule. In some such cases, exceptions only, it is it is not cancelled each other. So it is not dipole moment is not equals to 0, it is a polar molecule. Dipole moment is directly proportional to electronegativity difference. Fluorine has more electronegative than fluorine. Chlorine is more electronegative than bromine. So electronegativity difference is more for here HF molecule, then HCl, then HBr and HI molecule. So dipole moment is more for HF than others. Dipole moment is directly proportional to lone pair electrons. HF is greater than H2O is greater than NH3. If take this electronegativity difference and lone pairs, if observe, see HF electronegativity difference, fluorine electronegativity is 4, hydrogen 2.1, the electronegativity difference is 1.9, and for H2O 3.5 for oxygen and 2.1 is electronegativity for hydrogen, the difference is 1.4. For NH3, nitrogen electronegativity is 3 and hydrogen electronegativity is 2.1, the difference is 0.1. 1.9 is more than 1.4 and then 0.9. Electronegativity difference is more for HF than H2O then NH3. So dipole moment is greater for HF than H2O and NH3. If observe lone pairs, here dipole moment is directly proportional to lone pair of electrons, number of lone pair of electrons. If molecule is present 3 lone pairs, that is more dipole moment than 2 lone pair containing molecule. If observe that example, HF, here 2 pair, 1 pair of electrons bonded and 3 remaining are lone pairs in HF molecule. In H2O, here if you observe 2 lone pairs and 2 bond pairs. In NH3, 1 lone pair present. So dipole moment is more for HF, then H2O, then NH3, because here 3 lone pairs, 2 lone pairs, 1 lone pairs. Dipole moment is directly proportional to number of lone pairs. See, if take one example, CH3F, CH3Cl, CH3Br, CH3F. Here man actually in general trend fluorine is more electronegativity, so it has more, it should be more electronegative, it should be molecule has more dipole moment than others. But here exception is CH3Cl has more dipole moment. This was experimentally proved, and because of distance, actually size increases, bond length increases. Here distance effect that increases the dipole moment. So it is one exception. That's all for today. Thank you for watching.